Hey guys, and welcome to a new video. We have a new state-of-the-art object detection model from Deci. This is called YOLO-NAS. So this is actually like a pretty nice model. We're going to go through all of it. I'm going to show you how we can set it up in Google Colab, how we can take our own custom data set, train it in Google Colab, and then also how we can deploy them, get results, and so on. Again, this is a new state-of-the-art performance on object detection. We're going to see some graphs. We're going to go over the actual performance. It achieves higher performance, higher accuracy, and it also reduces the inference times compared to, for example, the YOLO v7 and also the YOLO v8 model. So we have a new state-of-the-art YOLO model. So we're going to show you how we can set up all of it. We're going to do the exact same thing as we did in the YOLO v8 video. Now we just have a superior to the YOLO v8 model. So this is going to be really interesting. So first of all, here we're just going to take a look at the graphs. We're just going to do a comparison of the new YOLO-NAS models. They also did some optimization to the model, quantization, and stuff like that, so we can even more improve the inference time. So the NAS stands for Neural Architecture Search. So again, this is not a new YOLO v9 model. This is YOLO-NAS. It is really good, as you're going to see in just a second. So let's now take a look at the performance of these new YOLO-NAS models compared to the YOLO v8, YOLO v5, and YOLO v7 models. We can see here in dark blue, we have the YOLO-NAS models. We both have an int8 version and also a floating point 16. So we also have this quantization aware architecture with this new state-of-the-art object detection model. We can see the inference speed down here on the x-axis. We have the latency in milliseconds, and then we have the accuracy on the y-axis, which is the mean average position. And again, here we can see that this is basically a benchmark on the Coco dataset for object detection. So this is an object detection benchmark dataset. We're going to take a look at some other benchmarks later on. But here we can see in dark blue, we have the YOLO-NAS models. They are basically just superior to all the other YOLO models. They're both faster for like inference, but they also have higher accuracy. We can see all these different dots here. It is basically just the different variations of the YOLO models. So we have like the small ones, medium ones, large ones, and so on. So here we can see the small ones. If we just take that as a baseline, we can see the small one here. It is faster than the YOLO v8 model, but it also has higher accuracy. So it's basically outperforming all the other YOLO models here. This is the new state-of-the-art object detection model. And we can even see here that we get even faster inference speed when we have this int8 version compared to the floating point 8 version. So we have this quantization, and we don't really like lose that much of accuracy here by actually like doing this quantization. So this is also a very nice benefit and advantage over the other models, especially when we're deploying the models in production and in the real life. So they're basically just making small changes here and there. Now we have like these models with focus on quantization, actually like deploying these models in production. And then again, we still get higher accuracy on the different benchmarks. So we're now jump straight into Google Colab. I'm going to show you how we can actually like set up the whole model here, how we can import the different modules, install it, how we can use our own custom data set from RoboFlow. Then we're going to train the actual model here, the YOLO-NAS model. We're going to see the results. We're going to see how we can export the model and use it in our own Python script. So again, this Google Colab notebook here, it will be available. I'll throw it down in the description. You can go in and use it. Just go through like all the blocks of code as I'm going to do now in this video. And then you can go in and train your own custom object detector on your own custom dataset. Again, we're going to go inside RoboFlow. We can just do that directly. I have this cup object detection dataset that we've been using in the other videos as well. So I also use this for my YOLO v8 video. We can basically just go up, export the dataset. We're going to choose the YOLO v5 format here for the YOLO-NAS. We can then show downloadable code, and then we're going to copy it, paste it into our Google Colab notebook when we're going to actually like import our dataset, so we can train it on our own custom dataset from RoboFlow or any other annotation tool that you're using. So now we're back in the Google Colab notebook. Let's just run these blocks of code to actually like install the different modules that we need. Here again, we need these super gradients from Deci AI. So right now I'm just going to use this version here because it's pre-launch. When it is actually like launched out there, it will just be like pip install super gradients. Again, everything will be in this notebook, so you can just directly execute it, train it on your own models without any errors. So here we're basically just going to run these blocks of codes here so we can install it, set it up, and also import the different modules. While it's installing here, we can just go through like the next couple of code blocks. So now we can just go in, use the super gradients. We can just have this great super gradients.training, import the modules, and then we can just directly go in and use the pre-trained models from YOLO-NAS as we're doing with YOLO-V8 and all those different kind of models. So we can basically choose between the large model, nano models, and also the small models. We can also choose the pre-trained weights that we're going to use. So we can use, for example, like just the cocoa if we want to use those. And then later on, I'm going to show you how we can go in and use a custom trained models. Instead of these pre-trained weights, we're basically just going to load in the weights that we have been training inside of this Colab notebook. And then we can basically just use it and create an instance of our model with a single line of code. Then we can just directly go in and use this model to do inference and do predictions on new images. So it is really easy to use. Again, it was the exact same thing with the YOLO-V8 model. It is also just a single line. But again, now we just have a better model that is performing better and also has lower latency. So after our modules has been installed, we actually need to go up and restart the runtime. You'll have to do this or else you'll run into an error. This is the only thing that you need to do. And then you should be able to run all the blocks and all the code cells without getting any errors. And then we can basically just run through it, see the results using our own custom data set. So now we can see that we are reconnected. We don't need to like pip install the modules here again. We just directly go down and run the block of code that we went over. So now we're basically just going to create an instance of our model. We're going to choose the large model here. Here we can see that it is basically just setting it up right now. We're exporting it right now. It's downloading it. So it's 256 megabytes. Again, it will basically just download it as it did with the YOLO-8 models as well. And then again, you can choose like whatever version of the YOLO-NAS model that you want. Now it's done like 86%, 87. So just wait here. After that, we can go down and actually generate a summary of our model. We can specify the input size, the names here for our columns. And again, we can do a lot of customization. We can get a summary if you're interested in seeing like how the architecture looks for this specific model. So let's just do that. And then we should be able to see the output here in just a second. So now we can see that we successfully installed Torch info, so we can get a summary of our model. So here we can see the output of our model. So these are all the individual like layers in our YOLO-NAS large model. First of all, we have like a backbone. We can see that it consists of a different like VGT blocks. So we have some convolutional layers. We have different stages in our YOLO-NAS model. First of all, we basically just have our backbone for extracting the features. We have some up stages as well here. So I think they're using some kind of like unit structure as well. It kind of looks like that. And then we also have the head layers here at the end. So we also have the down. So we have up and down here. So it kind of looks like a unit shape here or like a unit architecture using that and using some adheres for that. And then we have the head. So we have our backbone and then we have our heads for the classification and actually like finding the bounding boxes at the end here. Pretty nice model here. Pretty nice that we can get a summary. We can see the total number of parameters as well in our model. We can see the input size and also the parameter size here of our model. The total size of it. So this is actually like a rather small model compared to some of the other object detection models out there. So now let's just try to do inference on an example image here. This is basically just the image that we're going to throw it through. So here we just specify an URL. We can then have our YOLO model here. We can call the predict method on our YOLO model. We pass in the URL and then we'll get the results back. So this is basically just a forward pass of our image from this URL. You can pass in a URL, a NumPy array, and all those different kind of like data structures, and then it will do a prediction of it, return the results, and then have a method for actually like just directly showing the results on the image. So we just call .show. We're going to do the exact same thing when we're going to export it into our own custom Python script. But now we can see all the detections in this image here. We have some TV, persons, like a dining table, a bowl here. So we have some different kind of like bottles, even though this bottle here is occluded. So we can see that we actually like detect all the persons that we have in our image. So again, we have the model running. We can do inference on it. So let's just jump further. So you can read it through if you're interested. I don't want to like spend too much of your valuable time. So now we're going to see how we can fine tune the YOLO-NAS model on a custom data set from RoboFlow. Again, we have already copied it and then we can just directly paste it into the Colab notebook here. We can also do inference via Webcam. I'm going to show you that in just a second, where we're going to export the model that we've trained on our custom data set. We're going to see how we can throw it into our own Python script. We can open up a video capture with OpenCV as in all the other videos that we did here on this channel. But basically here, we're just going to take a look at how we can fine tune it. First of all, we can set up like the trainer. We have some different kind of like arguments. We have some different kind of parameters that we need to set up. But again, we're just going to like skip through those things like rather quickly. I have all of it covered on my YouTube channel here. I have a whole playlist going over like how we can train models, all the different kind of like high parameters. What does the high parameters do when we're training the models? I explained the high parameters and also the most like default or like common values for the high parameters. So definitely check that out if you're interested. Or here we're basically just going to go through the blocks of code. First of all, we set up our checkpoint directory and also our trainer. So again, we're just going to run this block of code. The dataset and the data loaders, we can just scroll down. You can use whatever tool you want to. You can use some like pre-labeled datasets here directly from RoboFlow, or you can choose your own. I have my own here. And then we have this code snippet here, or like this block of code. This is basically just where we have to paste in the export code that we have from RoboFlow. So I'm just going to do that in a second. Just make sure that you're actually changing your API key here, or else you can actually use this dataset directly. You just need to specify your own API key, run this block of code, and then we can go down and actually train the models on our custom dataset. So I just pasted in my code snippet from RoboFlow from the export, and now we should actually have extracted our dataset. And yes, we can see we have it inside of our files. We have our cop detection, we have a test, train, and validation split. We also have some other different kind of like information. We have test, we have the images, and also the labels. So now we can just directly go in and use this. Now we need to set up our data loaders and also our Cocoa data like format. So we're actually going to pre-process the data set, and we're also going to specify the correct format to be able to train this YOLO-NAS model. So now we have the dataset parameters here. We just need to specify like the dataset. So right now we have this data directory. We're going to use our own custom one. So we're actually just going to specify cop detection. And then we have a one as well. So this is the dataset directory. We have all the directories for our training images, training labels, validation, and so on. And now we also need to specify the classes down here. So here I actually think that I have two cops in my dataset. So I'm just going to specify that, one with an uppercase and one with a lowercase. So just to make sure that we are using the same labels. We can just run this dataset parameters here. So now we basically have a dictionary with all the parameters that we can use later on. So now we can actually just go down here and set up our data loaders. So we have our train data, validation data, and also our test data. First of all, we have this Cocoa detection YOLO format train. So it's basically just converting between the different formats for our data sets. So we don't need to take care of that. We're basically just throwing in our dataset parameters and also our data load parameters. So we can specify the batch size here and also the number of workers that we want to use. Here we're just going to go with 16. You can also like choose 32 or something like that. But let's just run this block of code. Here I'm just going to go out of the file so you guys can better see what's going on. So now this block of code is done running. We're casting the annotations, so now we can see that we have loaded in our data. Then we're going to set up some transformations for data. So we need to like pre-process our data before we can throw them inside our model. So we're just going to do that. We're just going to expect the data set defined earlier. So transforms are inside a dictionary. So we basically just need to go in and index those. We're just going to do that in these blocks of code. And then we can go down, take our train data, .dataset, and then we can plot a batch of our training data with the arguments applied. So we can see what our dataset actually looks like before we throw them into our model. So this is the train data. We can see that a lot of data augmentation has been applied on this dataset as well. But we can see all the cops here in our dataset. And again, we have 16 images from our batch. We can also see the bounding boxes around our cups here. So this is basically the images that we're going to throw through our models. We both have the images and also the annotations with our bounding boxes. So now we just verified that we have the correct data loaded in. Now we can instantiate the model, throw it through the model, train an actual model, and then we are going to see the results. So we're going to create a model exactly in the same way as we did in the top. We're going to have the YOLO-NAS model. We're going to specify the length of our classes. So we're basically just going to specify the number of classes that we're using. Pre-trained weights, we're going to use Cocoa. So we're just going to use transfer learning. And then we're going to fine tune a model on our custom dataset. We're not going to train it from scratch. We're going to use the pre-trained weights from the Cocoa dataset. You will probably always do that for your custom dataset. So now we just run this here and actually just create an instance of our model. We can define the metrics and the training parameters. We won't go into details with that. Again, I have all these things covered in my other videos here. I have a whole playlist with that. We have the training parameters. We basically just set it up. We have like warm-up mode. We have the learning weight, warm-up epochs. initial learning rate. We also have some optimizers, so we're using the atom optimizer. We can see the learning rate. We can see we also have a weight decay for our optimizer. All these different kind of parameters. We also have the number of epochs, so this is probably like the most important parameters. It should probably be okay to run with these default parameters on like any of your custom data sets, though the most important parameter here is probably the max epoch. So here we're just going to train it for 10 epochs for this example here. If you want to get higher accuracy or your model is not done training, you can basically just like increase the number of epochs. It also depends on how large your data set is and how complex your data set and task is. We set up the loss here and all these different things. Again, I want to go into details. We're using 10 epochs, and then we're just going to run this block of code, make sure that all is set up. Now we can go down and actually just train the model. We have set up the trainer, we have defined the dataset parameters, we have set up the data loaders, we have created an instance of our model, we have also set up the training parameters, and now we're ready to train our model. This is really easy to do. We just have our trainer set up. We just call the method .train. We specify the models, training parameters, the train data set that we want to train our model on, and also the validation data that we want to validate our model on during training. So let's just hit this here. We're going to run this block of code, and now our model is actually going to train. Again, you guys can just see like how easy it is. Again, this notebook here would be available down in the description. You can just directly go in and take it, train it on your own custom data set, and now you can use this new state-of-the-art object detection model called YOLO-NAS. You can just follow through here with this training process. First of all, you will get some information about like the parameters, so the batch size per GPU, the number of GPUs that you're using, iterations per epoch, and so on. And then after that, you will be able to see the training accuracy and so on per epoch. So this is just awesome. We can just take a notebook, we can just export our dataset from Roboфlow. We don't have to write any code at all. Then we can run the whole notebook through, and then we basically have a custom object detector that we can export and use on our own applications and projects. So it has never been easier to train these models here, to actually like use them, and then we can deploy them, use them in different kind of like situations, in production, in the real life. So now our custom model is done training. It took around like 8 minutes to run through 10 epochs. Over here to the right, we can see how the mean average position 0.5 is increasing over time. So we start at a really low accuracy here, or like the mean average position, and then it basically just increases over the number of epochs. And then we can see that it basically just ends up at 0.995 here, which is pretty good. So even after just like 5 or 6 epochs, we already had a pretty good object detection model. Again, it only took like 5 minutes to get to this stage here. So let's now go down and take a look at how we can get the best model that we trained throughout the number of epochs. So they both have this model here with the best weights and also the last weights. So they also use something called like an average checkpoint. So it's basically just using the weights average across like all your training runs. So if you're doing like multiple training runs, it will average those models together, and then you can use the average models instead of just using like the best one or the like last one in your training run. So let's now go down and see how we can get the best one here. If we go over here to the left, we should get the checkpoints. So this is basically my first YOLO-NAS run. We have the average model, the checkpoint for the best model, and also the checkpoint for the latest model. Right now, we're basically just going to download the best one here. I'll just go in, download it, and then we can use it later in our own custom Python script. So let's just close it down here. So now we're going basically just go in and create an instance of the best model. We choose the YOLO-NAS, the number of classes, and then we just specify the path to our checkpoint. So instead of using the pre-trained weights, instead of using like the pre-trained argument, we just use this checkpoint path argument. So let's now just create an instance of our best model, and then we can basically go in, call some other different kind of like methods. Like for example, we have the trainer. We can go in and test the best model that we have, but we can also go in and directly run inference on this model as we did with the examples up above. So let's just evaluate our best trained model here to start with. We just throw in the best model and also the test data set that we have. So here we can see some metrics about it. We have the loss for our class. We have the loss for our intersection over union. We also have like the overall loss. We have the position of 0.50. We also have the recall, mean average position of 0.50. I would probably also want to take a look at the average position of 0.5 to 0.95 with an interval of 0.05. But again, we can see that we have a pretty nice like F1 score. We have the precision recall, really use metrics, and also the mean average position is also very high, and our loss is also pretty low. So now we have all the metrics here. We can basically just evaluate our model. We can go down and do predictions on our best model. This is not the data set that we're using right now. So we can really just go in and take an image like this, but we can actually just go in and take an image. I'm going to show you that when we export the model, we're going to export the model. I'm going to show you how we can run inference in our own custom Python script, because that might actually be a bit more fun to do. We could also go up to the top here, or you can just go in, directly take an image. So it's not just to create another block of code here. I'm just going to show you how we can actually do it. I'm just going to copy paste the code directly from the custom Python script that we're going to take a look at in just a second. So we're basically just going to use CV2 or like OpenCV for that. So we're just going to import that to start with. So we have CV2, just import like NumPy just to make sure that we have that as well. So NumPy as NP. And again, when we're calling this predict function, we can also throw in NumPy array, so we can export it, use it as we're doing in all the other computer vision tutorials that I have on my channel. And then we're basically just going to like show the image at the end. Well, let's basically just run it through here. First of all, let's see if we can actually like get the outputs. So first of all, we just have imread here. We're going to specify the directory that we want to imread from. So we're just going to take a test image here, and then we're just going to choose the first one, and we're just going to copy the path. So let's just throw it directly into our imread. So we're just going to specify it here, paste it in, and we're going to close the files window again. So now we have the image, we read it in from OpenCV, we store it in the in variable. First of all, we don't really want to show it here. We convert it from BGR to RGB, throw the image through our model by calling this .predict. Let's just make sure that we have the correct model. So we're going to use the best model, and then we'll get the outputs. So just run this here and see if we're actually able to run it. We can see that we are. Let's just try to go down and print the outputs. Let's see what we get. So we should basically just get a class here. So let's just try it. There we go. And then if we go up here at the top, we can see after we have called this prediction, we can just directly call .show on our outputs. So let's just do that. So here we can just call outputs.show, and then we're just going to run it. And then we can see the outputs here directly in our Google Colab notebook. So this is really nice. Again, we can see that we have actually been able to train a model on our custom data set. We get some really nice bounding boxes around our cups here. We also get a pretty high confidence score. Again, this model only trained for like 8 minutes. This is really easy. You can just run through the whole notebook and do the exact same thing on your own custom data set. So this is really cool. It's really easy. Go down in the description. You'll get the notebook. Go through it. You'll learn a lot by actually just training your own deep learning, machine learning, and object detection models. And as promised, we're going to see how we can actually set it up in our own custom Python script. So we just export the model from the Google Colab. We're going to import the modules. So we're going to use PyTorch, OpenCV, and then also super gradients to get the actual models. We can either set up a pre-trained ones with the Coco dataset as we did in the notebook, and we can also go down and use the one from the checkpoint. So the checkpoint with the best weights. We can also go down and choose if we're going to use like CUDA or the CPU. Right now I'm on my MacBook, so we have this MPS available, or else if you don't have that, it is just going to use the CPU. If you have CUDA on your computer, it is going to use that, and it will run significantly faster, and it will run so fast with the CUDA enabled. And we're definitely going to create some videos in the future where we're going to use my other computer with my 4090 GPU with CUDA, and to see how fast these models can actually run, and how we can create like different applications around it. Maybe do some comparisons with the YOLO V8 and this new YOLO-NAS models, compared with real-time inference and all those different things. So definitely stay tuned for that. Remember the subscribe button and also the bell notification, so you get a notification when I upload new videos with the YOLO-NAS models. I'm definitely going to cover that way more in the future videos. This is an awesome model. So right now we're basically just going to convert our model to a device. We can also have this predict webcam that I'm going to show you in just a second. Then we can just directly run live inference on a webcam with a single method. Right now we're just going to run the exact same thing as we did in the Colab. We're going to read an image, a test image. We're going to convert it from BGR to RGB, and then we can also throw it through this predict method. And then we can just call this outputs.show to see the results in our own custom Python script. Or we can just take the results and do whatever we want to do with that. We basically just have an output class here where we can extract the information from. So let's just run it here. We're going to open up a terminal, and then it will basically just read in the image, set up the model, throw it through the model, do a prediction, and then we're going to get the output called .show, and we should see the results in just a second. So here we can see results. We get the exact same results as we did in the Google Colab notebook. So again, this is just to visualize and see how we can actually export and use it in our own custom Python script. So this is really nice, and then you can use it in your own applications and projects. So let's now close this one down here and basically just comment out these blocks of code, and now we can try to do it on our live webcam. So here I'm just going to copy paste those out, comment this one in here. We just have model.predict_webcam. Then we can run it. It will open up your webcam, and then we should be able to see how it works. So here we can see that the live webcam is now running. It is really low FPS because I'm running it on my CPU here on my MacBook. But again, we're going to create some other videos where we're going to run this on my 4090 GPU. Here we're detecting me as a cop, maybe because we don't really have, we have a pretty like static environment. We don't really have like too much variation in it. And we're basically just capturing images of my table. Let's just try to like take the cop over here to the right, and let's see if it's actually like able to detect this one here. Maybe it's not, because we still have a very specific data set for our specific example, and we only have like 80 images in our data set. So thank you guys for watching this video here. We're definitely going to create more videos in the future with this new YOLO-NAS models. It has state-of-the-art performance for object detection. We're going to use it for different applications. I'm excited to run it on my Windows computer, where I have my other graphics cards, so we can run it together with CUDA, maybe create some applications around it, see how it performs on real live webcam feed compared to the YOLO-8 model, maybe also some of the other YOLO models, just to see how it performs over those when we're running on the GPU and in our own custom Python script. So thank you guys for watching it again, and I hope to see you in the next one. Bye for now.